Hello everyone, today we are studying the structure and working principle of shock absorber. Mission statement, Mr. Lee's Geely EV450 situation of 120,000 kilometers. The vehicle driving to the bumpy road found that the body posture of the phenomenon of excessive bounce, wobbling, at the same time the shock absorbers issued a strange sound. The wheels appeared to tilt and so on. According to our knowledge to help Mr. Lee to solve the problem of this phenomenon, there are 3 learning objectives. 1. Get an overview of shock absorbers. 2. Knowledge of the working principle and working requirements of shock absorbers. 3. Mastering the structure and working principle of two-way acting vibration damper. Next, let's learn about the first part of the shock absorber overview. When the car is traveling on uneven roads, the body will vibrate. In order to accelerate the attenuation of automobile frame and body vibration and improve the smoothness of automobile driving, automobile suspension are equipped with dampers and elastic elements installed in parallel in the frame and axle. Part 2. Working principle and working requirements of shock absorbers. 1. Shock absorber working principle. The workpiece principle of the damper is to utilize the resistance of liquid flow to consume the vibration energy and make the vibration disappear. When the frame and axle relative movement, the damper fluid will be through some narrow holes, slits and other channels repeatedly flow from one chamber to another. When the whole wall and the friction between the fluid and the friction between the molecules within the fluid formed on the body vibration resistance, this resistance engineering known as the damping force. The damping force converts the vibration energy of the body into heat, which is absorbed by the oil and the housing. The damping force of the damper increases or decreases with the increase or decrease of the relative speed between the frame and the axle, and is related to factors such as the number of orifices, the area of the channels, the softness or stiffness of the valve springs, and the viscosity of the oil. 2. Working requirements for shock absorbers. In order to better realize the smoothness and safety of the sedan, the damping coefficient is not fixed at a certain value, but can be changed with the state of the sedan operation so that the suspension performance is always in the vicinity of the optimal state. The damping force of the damper is too large, although the vibration attenuation is too fast, that the body is subject to a larger impact, which is not conducive to the improvement of passenger comfort. For this reason, the following requirements are placed on the work of the damper. 1. In the compression stroke of the suspension, the damper should have a small damping force to fully utilize the elastic effect of the elastic element to moderate the impact of the road surface. 2. During the extension stroke of the suspension, the damper should have a large damping force to rapidly attenuate the vibration energy. 3. When the relative speed between the axle and the frame is too large, the damper should be able to automatically increase the area of the oil flow channel in order to limit the excessive growth of the damping force to avoid the damper to withstand excessive impact loads. Part 3. Structure and working principle of double-acting vibration damper. There are 2 types of damper, unidirectional and bidirectional. Only in the extension stroke of the vibration damping effect of the damper for the unidirectional action of the damper. In the compression stroke and the extension stroke of the vibration damping effect of the damper for the two-way action of the type of damper, the current automobile is widely used is the two-way action of the cartridge type shock absorber. There are also 3 types of dampers, which include gas-filled dampers and resistance adjustable dampers. 1. Double-acting cylinder damper structure. Double-acting cylinder damper structure as shown in the figure, including upper support, piston rod, oil storage cylinder body, pressure cylinder, bottom valve, lower support, and so on. 2. Working principle of double-acting cylinder vibration damper. Compression stroke. The piston moves down so that the volume of its lower chamber decreases. The oil pressure rises, and the oil enters the upper chamber of the piston through the circulation valve. Because the piston rod occupies part of the volume, so that the volume of the upper chamber increases less than the volume of the lower chamber decreases, so that the lower chamber oil cannot all flow into the upper chamber, Then the excess oil open compression valve flow back to the oil storage cylinder. When the body vibrates violently, the opening of the compression valve increases, so that the oil pressure and damping force will not be too large, so that the buffering effect of the elastic element can be fully utilized. Extension stroke. The piston moves upward, so that the volume of its upper chamber decreases. The oil pressure rises, and the oil enters the lower chamber of the piston through the extension valve. Because the piston rod occupies part of the volume of the lower chamber decreases less than the volume of the lower chamber increases. The oil in the storage cylinder flows into the lower chamber through the compensation valve under the action of vacuum to compensate. As the spring stiffness and preload of the extension valve is greater than that of the compression valve, and the channel cross-section of the extension stroke is smaller than that of the compression stroke, the damping force generated by the extension stroke is much greater than that generated by the compression stroke, so as to achieve the requirements of rapid vibration damping and to protect the elastic element from being pulled out. Okay, that's the end of the lesson.